Our next speaker is Dr. Daniela Pieraccini, teacher at IC and Cici Cola Salvetti in Livorno, Italy. I probably totally screwed that up. And her talk is on teaching AI with humanity, breaking barriers, a journey into ethical and inclusive artificial intelligence through hands-on, student-centered learning. And yes, use this one.
Okay. Good afternoon to everyone. I'm really happy to be here in front of you to share my project entitled Teaching AI with Humanity for Breaking Barriers. That is a sort of journey that I want to share with you in order to let you understand which kind of insight my student had in that particular experiences. I came from Italy, Tuscany, to be exact, where I teach in a school, a public school, with students aged from 3 to 13 years old, even if my students are a little bit older, from 11 to 13 years old. In my school, I work with innovative methodologies, and I design a special STEM curricular for my students, and you will see some picture about this. And I am also involved with many national groups working on AI, that is MIAS, for example, or Impara Digitale, or Fondazione Mondo Digitale, which are a national group of researchers that want to teach students AI from an ethical point of view, innovation, and also inclusive point of view. When I decided to design this kind of curriculum for my students, my colleague asked me, why teach AI to young learners? I reflected on this, and I realized that young learners are surrounded by AI, but Italian learner, for example, don't realize it because they don't know how AI works. So it is crucial to equip them with tools to interact, to engage with AI from a critical point of view. Moreover, inclusive education calls for strategies that support students with special needs, and AI tools seem to be effective in that way. So I decided to build a curriculum that address both the need in order to engage my students with AI, not just as a tool, but a system that can shape their future possible in a better way. Here are the goals of the project: introduce AI and machine learning concept through hands-on activities, develop inclusive tools using block-based programming environment. That because present research has demonstrated that block-based programming environments are very useful to teach adolescents to critical thinking and knowing how machine learning works. And they are really engaging systems. So I decided to use block-based programming integrated with AI to obtain my goals. The project aligned with sustainable development goals, more in particular the fourth, which is quality education, and the 10th, which is reduce inequalities. The project was made with a heterogeneous group of 28 students aged from 11 to 13 years old with completely different family and cultural backgrounds. And it was a multi-step approach that as the outline that you see here, the horizontal timeline that I represented. Before going deep in the insight of what machine learning is and what AI works, I started with a sort of exploratory phase through which my students were engaged in guided discussion in order to understand that AI is not like sci-fi. When I asked them what they thought about hearing the word AI, I realized that they have no idea, but many of them answered robot or computer or films. So through a sort of brainstorming, I tried to let them understand that AI was around them. YouTube and pay TV and many, many tools that they deal with in everyday life. After this exploratory phase, I moved on unplugged activities through which I try to let them understand some key words, key principles of AI, such as data set, or training models, or bias, and everything was done with unplugged activities. For example, I use an unplugged activity, giving them a lot of words. They have to cut and use it to answer a question that I made. They were divided into groups. And with these simple activities, they realized that the question was the same, but each group gave a different answer. And that was useful for me to let them understand how GenAI is working it. And cutting the word in two parts, I try to let them understand what tokens are, but there were unplugged activities. Then we moved to tech-mediated activities, because I use Teachable Machine with Google and Machine Learning for Kids to train a supervised model. Then we try to improve the model, and then we import the model in the block-based learning environments. And after this, we share the result and try to fix possible error and something like this. Okay, sorry. Okay, here is a table in which I collected all the results that I had working with Teachable Machine with Google and Machine Learning for Kids. I started with Machine Learning for Kids. As I work in Italy, we have a lot of restriction with the use of AI platforms. And I selected Machine Learning for Kids because it allowed me to create a teacher account and to create a classroom without using the name of my students. So it was perfect from to respect privacy, for example, and data collection, but it is not free of charge. So after 15 days, I have to pay, and because of some economical constraint, I have to stop it and pass to Teachable Machine with Google, which is free of charge. In that case, I have some problem when I try to save my supervised model, because it needs drive, but I solve it. So most of the things that you will see are done with Teachable Machine with Google. Okay. The group of the students were divided into groups, collaborative groups, where that collaborate each other, and I try to act as a guide for them. Okay, so I create the appropriate environment in order to let them safe to express themselves, to experiment, and to talk each other in order to fix possible errors that they encounter on all the project. I gave them feedback, but I try not to give them the answer, because I want them to do mistakes and try to fix it. I know that maybe it seems an obvious way of doing with the students, but in Italy, situation is not like here. Many times, teachers use traditional methods, and Italian students doesn't want to do mistakes. they doesn't like. And when it happens, they become anxious. And so I try to do all that I can to let them experience error as a part of the training and of the learning. Okay, here is the first task. I think that many of you have experimented to have a student with a broken legs that need a wheelchair, or sometimes it happens that students with needs a wheelchair because they have special needs. And one of the things that they experience, it is the frustrating of not being able to drive the wheelchair by themselves, so they lack in autonomy. So I asked to my student, because one of the classmates have a broken leg, what can we make to help him in this situation? And okay, and the answer was try to build, to realize a sort of wheelchair that respond to voice command. Obviously, we didn't build a real wheelchair because they are too young, but maybe in future it will happen. We create a sprite with a wheelchair, a sprite that is that moves according to voice command. Students selected appropriate voice command, and that was really, really important. They use short words, and they recorded voice, single voice or multiple voice, and they trained a supervised model, imported, verified if everything was okay, imported in the programming environment, and tried to understand if everything was okay. Okay, here you find some of the insight that they had. I said you before they have to select the command because they realized that some words led to misunderstanding. For example, if they use su and giù, that means up and down, su and giù are too similar and led to confusion. Destra and sinistra, which is right and left, have to be pronounced very well. Whereas avanti and indietro were perfect. They recorded they trained a model using single voice speaker or multiple voice speaker. The model that were trained with multiple voices were more accurate in recognizing, but have a problem that should activated even if the words were pronounced not by the owner of the wheelchair, and that's to be avoided. So we decided to use the single voice model, even if it was a little bit worse than the other. Okay. So here you can find some of the results, and students were very proud of themselves because they realized that the sprite moves, and we let the sprite write the command so they can realize if something was wrong. Okay, here is the second task that I gave to them. We were thinking about students affected by autism that many times are in difficulties in recognizing emotion of other people through the facial expression. So the idea was to create a sort of assistant, a virtual assistant based on AI to help them recognize this emotion. This was a more difficult task. By the way, they selected appropriate images, some of themselves, some in the web, and realized that they have to collect a lot of images of many people, young people, adults. They created a training data set, they trained the supervised model, and they validated it. Here you can find the result. They realized that some expressions were not so easy to be understood, especially sadness versus neutral. Okay. Okay. Because they are too similar, okay? But they had a good result. The project was effective, and I think that the most effective elements is the collaboration and the fact that they had inclusion in practice, so they feel important and they understand how AI works. That's all.